So good morning. We are going to work on exponents and logs, but I did just want to have a quick little chat. As we all know, diplomas were announced last week to be optional, and there's a couple of things that I could say to that. I have had a few inquiries from grade 12s about, well, should I do it? Does the program at that university need it? And my question back was, you need to try to do your due diligence and find out if the program you're going into would look more favorably on your entrance if you did it. Okay. I kind of think, if you want my opinion, you're probably okay not doing it if you don't want to do it, but I would investigate, if you're trying to get into a nursing program where I know it's very hard to get into, maybe engineering, you may want to ask those questions of the institution that you're going to. I would say you're probably going to be safe not doing it. So that's kind of one thing. Second thing, it's not been decided yet as to whether we're going to have a final exam. If you want me to hedge my bets on that, I would say no. And the reason I would say no, if I'm okay to do that, is you've all, by the end of the time, will have taken 8 supervised tests from either a teacher supervising you or a coordinator at a school supervising you. So we've tested you, right? So I'm thinking we probably will be okay not to have a final exam. So again, to be announced. And the other thing that I'm investigating, I was trying to get a hold of my friend who happens to be an ATA rep because she would know this answer. At the moment, my final due date has not been changed. It's still January 8th because my marks are due to the office on January 11th and they're supposed to go to the government, etc. But I have heard rumblings that final date for my marks to get into the office to get sent to the government has changed. If that's the case, we may see the final due date change a bit. So we'll see how that all shakes out. When I know, you will know. Okay, so those are kind of the things that I wanted to chat about. So certainly, I just got a request for a question. We'll see if we can work that in, and you guys can just let me know. Okay, so off and running we are. We're doing exponents and logs. And I know that everyone's at a little bit different spot. Some of you guys are just finishing up the assignment, and some of us are still not quite engaged in the module. So I'm just trying to walk a little bit of a fine line to helping students that aren't here and helping you that are kind of at the end. So we'll see how well I walk the tightrope. Some of the questions we're going to start with are going to be the exponent questions, and then we'll move into the log questions. The exponent questions, the one I'm going to start with, or the ones I'm going to start with, sort of are a throwback to Math 20-1. I don't think you go to quite the difficulty that we go to, but certainly you've seen something similar. So when we talk about exponent questions, you have to know all your exponent rules. And I'm not going to take the time to go back in through the exponent rules, because exponent rules were, you've done them in grade 9 and 10. As we get to a question, we'll absolutely talk about them, but I'm not going to list all 5 and spend the 10 minutes to do that. We do need to know how to do that. And then I'm going to look at exponential equations and how to solve those, and dealing with the equations. And the other little thing that we'll talk about is being cautious about rewriting exponential expressions. With a common base. So that's what we're going to investigate for exponents to start. And then, like I say, I've got a couple other things on our list, and then I'm going to go into logs. So the type of questions that I'm alluding to will look something like this. We'll start with a really straightforward one, and then I'll kind of blast off into a harder one. So let's say that we're given something like 3 to the x equals 9 to the x plus 4 power. Okay, so to me, that's a fairly simplistic one. The steps are that we're going to have to try to rewrite them with a common base. Now be careful, you're not multiplying both sides by anything, you're just rewriting. And so I could make a little note here that you're always trying to go to the lowest common base, not the highest common base. So here, when we look at the 3 and the 9, and I set this up obviously to help us, have it work nicely. We know that 9 is 3 squared. And so we can just go 3 to the x equals 3 squared, and then put the x plus 4 in brackets. And then something to note here is once we have a common base once on each side, we cancel them and solve. And I'll show you one where we don't have the common base. Once we have it more than that, what do we have to do with that? So then we're able to cancel these out and get x is equal to 2 bracket x plus 4. And then we have a really simplistic linear equation to solve. X equals 2x plus 8. I'll subtract the x on both sides. And we'll get 0 equals x plus 8. Subtract 8 on both sides and get x equals minus 8. So I would consider that a simplistic question. Probably saw something like that in 20-1 to do. Okay, so have a look. I'm going to try to move. This worked yesterday pretty well to kind of move my board over and now do a harder one. And I believe before we came in, I did find a harder one on lesson quiz. That one's not that hard because there's some on the assignments that are certainly cranked up from that. I think I can make something up. These ones are not terrible to make up. Okay, so we're going to solve again for x here. And let's look at something that would be probably significantly harder. So we'll do the cube root of 8 to the x plus 2 power multiplied by 16 to 3x minus 1 equals 4. Nope, I'm going to make it even tougher. Might as well just throw it all in. 1/4 to the x plus 4 power. Okay, beautiful. Oh, so much fun to make up questions. Not really, but, and it looks kind of tough, but I think we can break it down and you'll see it's not horrible. There are more horrible questions. So we're talking about making common bases. So again, going to the lowest common base here, not all of them can be the lowest common base. Oh, this was supposed to be cube root. Sorry, I missed the little 3 in there. It would be a little tougher if I made it square root, so we'll leave it with cube root. So we're going to try to break things down to the lowest common base. And I always suggest go to prime numbers, go to 2, 3, 5, 7. And so I would take 8 and recognize it was 2 to the 3rd power. Hopefully you know that. If not, just do the common prime factoring. 16 is 2 to the 4th power. 4 is 2 squared. So you notice that I'm trying to rewrite them all with a base of 2. And again, going down to the lowest base is usually the preferred way of going through. So we're going to write this down, and this is not the only way to do this. It's cube root of 2 to the 3rd, and x plus 2 is up here as a bracket. And then this is 2 to the 4th to the 3x minus 1. And this is 1 over 2 squared to the x plus 4. Okay, like that. All right. Now, the cube root of 2 cubed. So again, this guy and this guy will cancel. So we will get 2 to the x plus 2 multiplied by 2 times 4 to the 3x minus 1. And then if we wanted to on this side, we have the base is on the bottom. Do you guys remember that you can write it on the top of the negative exponent? Here's where the exponent rules come in. So this could be rewritten as 2 to the minus 2 all to the x plus 4 power. Okay, so that's an exponent rule. Now, remember back here I said we were going to do one where we didn't have double bases. on this question, we have a base written twice here and only once here. So we cannot cancel bases yet. We have to do combining. So do you guys remember the rule that if the bases are the same and multiplied, you add the exponents? Like, let me give you a really quick question. If you had x squared times x to the cubed, it's x to the fifth. You add these. Oh, sorry, thought I turned my sound off. It's one of the teachers. I'll get back to her. So we add the exponents here. So same thing here. We've got a base of 2. We're going to get x plus 2 plus 4 times 3x minus 1 equals 2 to the minus 2 times x plus 4. All right, now we're able to cancel the 2's. And as soon as you're able to cancel your bases, in my mind, the question becomes quite simplistic because it's just a linear equation. And I know you guys are quite brilliant math people. So then we just get rid of the brackets, reorganize, and solve. Okay, so just do that. If you, it looks like many of you are copying this down. I'll quickly do it without chatting and you can just double check. It's probably going to be an ugly answer, but that's okay. Oh yeah, that's a pretty ugly answer, but anyway. Minus 6 over 15, which reduces to that's not terrible. Minus 2/5, I think. Okay, look over my work. Please let me know if I've miscopied anything. I'll double check. Don't think I made any transposing errors or anything, adding. Okay, all right, and we're done. And we could verify the answer by putting minus 2/5 back up into the question. Okay. Any questions so far? I will pause the recording just so we can have a chat if we need to. Okay, so the next exponential thing I want to talk about, and I thought I talked about it in this class, but it comes up in every single math class, so I don't think I've talked to you guys about it, is compound interest. Have we done any compound interest questions yet in tutorial? No, don't think so. Okay, well, we're going to talk about some compound interest questions. On the formula sheet, there is no compound interest formula. So if you're making a separate formula sheet for yourself or notes or whatever, try to highlight this so that you know how to use this formula, because it is easier than any other method. There are other methods to do it. If you remember back to sequences and series in 20-1, there you could do it as a geometric sequence, but it's just a little more complicated. So we're going to use the compound interest formula. So we should identify A, P, I, and N and see how they kind of interrelate. And then I'll do a question and that will help you on some of the compound interest questions that you see that come up in the assignments and quizzes, etc. Okay, so let me identify what the letters stand for and how we'll go about finding them, and we'll do a question. Okay. So A is the ending amount, what we will come out of the example with. P stands for the word principal, not the principal at a school, but that's just the starting amount that we have or that we owe, right? Could be an owing thing as well. I is the interest rate as a decimal. Be careful about that. Decimal that is paid each time. And I'm going to flush out why I am kind of specific about that, paid each time. And N is the number of times we are paid interest, or we pay interest, whichever way around if we're borrowing money. Interest, sorry. Let me make sure that's spelled right, interest. Okay, so again, I'm hoping you remember a little bit from 20-1, but depending on how your teacher might have approached it, they might not have used this formula. You do get a little bit of my preferences as we go through. Okay, so let's do an example here. Who am I going to pick on today? Tyler. Okay, Tyler's got money. Do you got money, Tyler? But you are having money today. Okay, so here we are. Tyler has, we'll just keep the numbers fairly easy. $1,000 to invest. He invests it, sorry, in a GIC at, oh gosh, you probably can't get very much percent, but let's say 4% per year compounded. Well, let's just say semi-annually. We'll talk about all that. We'll unpack all that in a second. How much money will he have wow, having a hard time writing this morning. I don't know, 7 years, let's say. Okay, so in this example, I don't know if you guys know what a GIC is, but it's just a kind of a certificate you buy that from the government that is stable and tells you how much interest you're going to earn. Sort of like lending your money to the government, and then they give you interest back at the end. So you got $1,000, you're going to try to make some money off of it. You invest it for the full 7 years, 4% compounded semi-annually. How much money will you have at the end of the 7 years? Okay, a couple things are important. This /A, whoops, this /A here means per annum. So this is saying we're getting 4% per annum per year, but it's compounded semi-annually. Okay, so this is probably the key to the question. I don't want to do that. I'll just underline it in green. This is the key to the question here. Okay, let's write down everything, the A, the P, the I, the N, roll it out and rock and roll. So we don't know how much he has. That's what we're after. We're after the A value. We do know that he has $1,000 right now to play with. Now it's 4% compounded semi-annually as a decimal. So it's 0.04, but semi-annually means that we're going to divide it by 2, and every time we get paid every 6 months, they're going to pay us 2% or 0.02. Okay, so again, I can do some color coding here. The semi-annually is why we divide by the 2. Now, whatever we divide the interest rate by, we multiply the years by, because we've got 7 years, we're getting paid every 6 months in the 7 years. So it's 7 multiplied by 2. We're going to get paid 14 times. So that number, whatever we divide by an E and I, we multiply by an N. And once you get all of that set up, this is pretty simplistic to get it in the formula and get the right answer. I rarely have people get the wrong answer, but sometimes they set that up incorrectly. So let me just move my board a little bit. So what we're getting set up to do in our calculator is 1,001 plus 0.02 to the 14th power. All right, so we're just going to throw this in our calculator and pull out an answer. Okay, so we've got calculators handy dandy. We'll see how much Tyler's going to end up with at the end of the time. Why don't you guys send me a private message? It doesn't come up on the recording, so you're fine to interact that way. Oh, good. And I never said this is a money question, so it goes without saying, but I wouldn't, if I didn't say it, I wouldn't deduct marks. We should have dollars and cents. So we should have 2 decimals. All of the answers that came in, I would totally accept if I hadn't, delineated to the nearest hundredth. So it looks like we're having no issues here getting the answer. So we would have, or he would have $1,319.48 if we rounded to the nearest hundredth. Okay. So another question that can be asked, be careful. I think this might come up on the test somewhere. Not sure, but it might ask how much interest did he earn? So to find the interest, the overall interest in dollars that he earned, we have to do a simple subtraction, but just watch that you read carefully. So in interest, the bank or the government paid him interest of $319.48. Okay, so just watch that in case you'd lose just a partial mark there. Okay, I'm just going to pause the recording to see if anyone has any questions. Okay, so now we're going to move into logs. And I don't know if this thought has come into your mind at all. Might have, might not have. You might not question things, but you might have questioned, well, geez, I've made it all the way to Math 30-1 and never needed logs, never felt the need or the worry. Why in the world is this new math, right? New thing coming up. So it's kind of nice if I can show you the need for logarithms and where they come from. So first of all, I'm going to show you the need to have them. And then the second of all, I'm going to kind of backtrack and show you where they come from. Okay. And there's a couple ways that we can show the need. So first thing I'm going to do is I'm going to talk about inverses. So let's say that we start with an exponential function. Y equals 2 to the x. Keep it super simple, because just to show this, we don't need anything hard. And then let's say I ask you to write the inverse. Remember inverses from module 1, and we actually did inverses in 20-1. Wherever the x is and the y are, we interchange them. So the inverse is x is equal to 2 to the y power. All right, now, can we, using our graphing technology that we have at our fingertips, which is most of us have something similar to this, can we put that into our graphing calculator written like that? If you go into the only way we have on these calculators to graph is, if you look up at the board there, y, or at your screen, y equals, and this says x equals. So if we wanted to try to access technology, we couldn't graph this. And therein lies the need to know how to write it in logs, because we can rewrite this, whoops, as log base 2 of x equals, I'm going to write y equals log base 2 of x. These two expressions mean exactly the same thing. Okay. Now, probably worth our while to do a little graphing, since I'm showing you, where logs grew from and why we would need this. So let's do some graphing. I see that I can see half the class right now, the way that I've got my screen set up. I'll try to make it bigger because I'm asking you to do something. Get your calculator out and just put 2 to the x power. Make sure your Windows settings are kind of normal, minus 10, 10, and 1. So we go 2 to the power of x and graph it. And then why don't you just put it up to your screen? Again, you're not being recorded, but I can still see you. So that would be awesome. And I just want to see that it looks good for everyone. So now I think I can see everyone here. Yep. All right. Just let me double check. All right, I see. Thank you. Perfect. 2 right, 3 right. Good. Perfect. Okay, everyone's got it. So that's not hard, but beautiful. Well done. Well done. So the graph of y equals 2 to the x. Oops, I don't want color. Looks approximately like this. It comes here and goes up like that. Important to note probably that it goes through the y-intercept of 0 and 1. That's approximately what it looks like. Now, remember what we know about inverses. We know that inverses graphically are reflected across the line y equals to x. So we need to figure out, sorry, just a second. We need to figure out how we would put in log base 2 of x in our calculator. Now this is going to be different for each of you depending on your calculator. I have a TI-84 Plus, but I have a real low-end version of it. So when I try to put log 2 of x in, I don't get the option of putting the base of 2. Anyone out there, let's just do this. Get back out to just a normal blank screen, because this will tell us in a second how I need to direct you guys to put this in. hit the word log on your calculator. It's down here on the side, like this. See how mine comes up and just is waiting for a bracket? Anyone out there have a little box that's subscripted, that's below, that comes up? Just put your hand up so I know that anyone in the class has that kind of. Okay, so we got one that does that. Awesome. You're going to have an easier way out than the rest of us. Anyone else have a little subscript right there? Okay, 2 of you. All right. So there's going to be a different variety of buttons depending on whether you have that. So I can just break that out for you. Many of our calculators do not have the ability to input a different base. And our numeric system is based on the base 10. So when I go in here and I hit the word log and go to put something in, it is assuming that the little base right here is 10. It just reads that into it. But we don't have base 10, we have base 2. So there is a change of base rule that you will definitely need to know as you go through logs. So I will write that here. So the change of base rule, this is on the formula sheet, so don't worry about that. I'll write it exactly as it's on the formula sheet with the same letters. Let me just go get the formula sheet quickly so I have the same letters in the same spot. So I don't know if you have a formula sheet handy. You do not have to get up and grab one or anything, but I will just write it the same way. So it says log base B of C. Log base B of C is the same as log base A of C over log base A of B. Okay, these are A's, I'm sorry. So when we use this change of base rule, I always assign A to be 10 because that's what our calculators are in. So then this could be then thought of as log B of C is the same as log 10 of C divided by log 10 of B. Okay, so if I'm going to work with the 4 of you that have a calculator like mine. If I need to graph this, the way we're going to have to put in our calculator is hit the y equals button to get to the y equals and go to y2. And then we're going to have to tell it to go log of x. So look at all the brackets, be careful, divided by log of 2. Log of x divided by bracket log of 2, like that. Don't know if I need my double brackets, but I'm trying to be careful. Those that have it, the 2 of you that have it, you're golden. It just, you hit log and you're able to put the 2 in there just as is in the x. I'm a little surprised they allow those calculators, but I know they do. So you guys you're the lucky ones. Okay, so let's put this in here. Bracket log of x, bracket, divided by bracket log of 2, oops, not 3, 2, bracket, and then hit graph. And hopefully you will see that it looks like that, like the inverse should. If you can't get that, let me know. Or why don't you just do the same thing you just did a minute ago, because it's not on the recording. Show me your calculators. I've got you guys all big enough that I can see. Okay, good. 3 of you, good. Perfect. One last person. I could just send them a message. I'm trying to stay away from. Okay, so I had a comment. If I press Alpha window 5, you can get the subscript. I don't think I can on my calculator. I'll go see. Alpha window 5. No, see on mine, I can't. I just can't. Mine's just too old an iteration of it to do it. So I have to go the old-fashioned way. But what we're trying to show here is, obviously we have to get acclimatized to our calculator, is that everyone should have gotten the inverse, which I can put on here. I'll do it in green. To look something like that. Okay. The x-intercept this time is 1 and 0. and it's a mirror image across the line y is equal to x. So the whole reason, I just got a question there. Sorry, I'll answer that question in a second. The whole reason that we went through this procedure was to show you the need for logarithms, right? That's how I started this conversation, was why do we need them? Well, we need to be able to graph them somehow, and not always using technology, but it's certainly something that we're, introduced to. So it is something that we want to do. I'll address that question in just a second. I had a question asked in private. It'll lead in after I talk just a little bit more about logs, so I will not forget that question. Okay. Now, something that is important, and I don't know if you guys are going to have trouble changing from exponential form to log form, but I always tell my students this story that I was educated in British Columbia, just on the other side of the border in beautiful Golden, BC, nice little town. And I went to Calgary, University of Calgary for university. And in my curriculum in grade 12, we didn't do logs. And so here I am in my first calculus class of, 300, coming from a school of like 15 kids in my class. And all of a sudden, all the Calgary kids, they're having coffee, they got their feet up, we're reviewing Math 30. And I'm like, oh my God. So I had to learn this really quickly. So I still have my notes. I actually dug them up to show my daughter, who's now starting to teach. I had this little memory tip on the top of every page for logs for a number of weeks until I didn't have trouble remembering. So here's my memory tip. You can use this memory tip or just think that Mrs. Van Duzen's a little crazy. It's all good. I'm good either way. So I know that this particular statement is true. 2 to the third power is 8. And then I memorized that this was the way of writing it in logs. Okay. And so when I was getting confused as I got into harder questions, like, oh, darn, which is the base? What happens? I would write this down and then I would see, okay, the base is the base. And then the other guys kind of change location. And I found this memory tip to be invaluable as I worked through log questions. Okay. Again, you don't have to use the memory tip, but you might find it to be useful. And you don't have to use those numbers. You could use something else with X's and Y's if you wanted to as well. Now I'm going to go back. I'm just going to pause and go back and read that question, and I might ask for some clarification on it. Okay, so let's talk about laws of logarithms for the last little few minutes that we have. The laws of logarithms directly come about from the laws of exponents. Exponents and logarithms are inverses of each other, right? I showed that with the graphing. And so all the laws we know of exponents apply to the law of logarithms. I'm not going to necessarily name these because that will take time, but let's look at some of the different things we would need to know. If we have something like log 10 of x times y, we can split it out into log 10 of x plus log 10 of y. Remember, this was called the argument that I just said a minute ago. If you have a product as the argument, we can break it out into 2 separate logs and add them. Okay, or if we have 2 separate ones that are added, we can combine them and multiply, either or. Another rule, if the arguments are divided, then we get log 10 of x take away log 10 of y. And I know if you're partway through the module, you know all this, but if you're new, this will be new. The other rule is if you have log 10 of x to the y power, the y can drop down in front as a numerical coefficient. Okay, that's called the power rule. I'm not naming these things. I don't think it's that crucial. Another one that you might want to know, you probably could do just fine without it, but anything to the base, any log that has the argument of 1 is equal to 0. Okay, so that's another one. This base can be anything, doesn't have to be 10. So with that in mind, we can do some questions where we mess around and try to reorganize. Okay, so let's just move these over so they're still on our screen. And let's just do some questions that would be similar to some of the assignment ones where it says simplify. So it's going to say something like this: log 2 of x squared minus 2 log 2 of y cubed. We'll just start with something like that. Don't make it too hard, and then I can jump in and do a much harder one. Now I combined a few things here. We've got the subtraction, so we've got that quotient rule, the second one, and we've got a number in front that arrived down on this one. So we have to be careful to do things in a little bit of measured order. The first thing we need to do is we need to pop this exponent back up top. So we get log 2 of x squared minus log, whoops, that should be a 2. I'm sorry, this should not be an x. That would be not usable. That should be a 2. Sorry about that. So it'd be log 2 of y to the 6. Bases have to be the same, so sorry about that. So we have to get rid of that coefficient first. Once everything is housed as part of the argument, part of the inside expression, then we can subtract, and we would get it rewritten as log 2 of x squared over y to the 6th. And that's as good as it would get. There's no other evaluating that can get done because I didn't put numbers in there. Okay. And maybe we could finish off by doing one with numbers that would make us work a little bit harder than that one made us work. So let's do that to finish. So let's say we're going to simplify again. So we'll have log base 3 of the cube root of 9 plus log base 3 of 27 to the quarter minus log 3, now let's put a 2 in here, of log 3 of 1. Something like that. Okay. So again, similar to example 1, we definitely have to deal with the coefficient in front of the last one. And along the line, do some other things. But I think to start, I would start here. I would just recopy this. You could make it, you know what? Why don't we do this? This might help us out. Let's make it 9 to the 3rd power because the cube root is 9 to the 3rd power. So at least we can do that. And there's no set way. You'll notice as I'm chatting, there's no real set way to do this, except you got to deal with this. So we get log base 3 of 1 squared. So really, the 2 out front there didn't even do anything. 1 squared is 1. Now that we've got everything written with at least everything housed as the arguments, we can make it one expression. So we get log base 3 of 9 to the 3rd power multiplied by 27 to the quarter power divided by 1 or 1 squared. So obviously we can drop that. Now that's not quite good enough here because you may notice that I made the bases like all work out to base 3. So let's rock and roll and do that. So we get log base 3 of 3 squared all to the 3rd power because 9 is 3 squared. And 27 is 3 to the 3rd power all to the quarter power. All right, so this is the entire argument. I'm going to put a big square around there so you know that that's all inside as the argument. So we got to continue to do a little bit more work there. Log base 3 of 3 to the 2/3, and we add, right? They're multiplied together. So we get 3 to the 2/3 plus 3/4. So find a common denominator. I'll give you a second to find the new exponent for 2/3 plus 3/4. Just a fraction question. Okay, let's double check. You guys were working on your paper. So the common denominator is 12. So the first numerator is 8, second numerator is 9. So we add them and get 17/12. Okay, now another rule that I didn't really talk about over here was if the base of the, so I can write it down here again. If this base is the same as this one, these guys, this whole thing cancels. And we get just y. Now that doesn't look very good, so I will get rid of the square around it. But when the base of the argument and the base of the log are the same, they cancel. So over here, now that we have this can cancel out with this and we get 17/12. Now, those of you that are in the middle of logs, that's probably fine. Those of you that haven't got there, I've probably just blown your mind a little bit because that got quite difficult quite quickly. Okay. All right, so I'm going to wrap up the recording and just stop it.